Hi, myself Sudharsan. I am assistant professor from Department of Petroleum Engineering from Amet University. I am going to give the presentation on Introduction to Oil Well Cementing. This topic is belonging to drilling fluids and cementation. Cementing, it is the part of the drilling. Now, when we have to do the cementing, first we have to drill a well. It may be reaching like some target or some depth. Once it is reached, then we have to insert the casing. If you leave only with casing and not cemented, means there will be the gap between the casing and the formation. Then what happens? It starts to shake. Your casing starts to be shaken. If you want to control this shake, then what we have to do? We have to cement this annular space. So this job is called as cementing. So we have to see why do you want to do cementing. The first one is it will support the vertical load whatever you are going to put on the well, top of the well, which means the vertical load, it might be BOP. The BOP, if I say that the load might be ranging from 450 pounds to 8,50,000 pounds. So if it is the only BOP stack, the weight is like that, then we have to put other equipments which is from the rig, which should also withstand. So if the gap is exist in the annular space, then what happens? Again it will start to shake and your well bore may be leading to the collapse. For that I have to preserve, what I have to do? I have to again fill the cementing with the annular space. So if I do that, then what happens? The seal will be created between the formation as well as the casing. Now your well become more stronger. So next is it is isolate the porous formation from one zone to another zone. Suppose my target is I have to reach 6,000 feet. If I want to reach 6,000 feet and I have reached 6,000 feet, my reservoir is exist. If 3,000 feet or 2,000 feet, if you found any water zone, then what happens? The water starts, if you don't put the cementing, the water starts to come from the 2,000 feet to your reservoir. Then your reservoir will be damaged, which means the reservoir now it may be contaminated, it may be getting another trouble. So everything, the reservoir characteristics will be completely spoiled. So if we want to stop this, what we have to do? We have to isolate the zone. It should not be interrupted from the one zone to another zone. How it is possible? We have to do cementing. If we do cementing, then it becomes very easy and the production wouldn't be disturbed further. And next is once you have entered to the reservoir, then in the production, what happens? The oil starts to flow to the wellbore. If I completely seal everything and only keep on opening on the only reservoir area, then rest of the fluids won't come to the wellbore. So that's what we have mentioned here. It is exclude the subsurface fluids from another area of your formation. Now it is helpful against the corrosion. If you go deeper, you will get many environment such as acidic medium and gas medium and another some poisonous gas which will create the corrosion to your casing pipe. So if I want to stop the communication between these gases, the gases are this kind of the environment which is coming from the formation. Again if you want to stop the communication between these two, what I have to do? If I put the cementing, automatically it will be, the communication will be stopped. So next is, of course, if you put the cementing, the abnormal pressure, whatever it may be in 1000 feet or 2000 feet. Once if you put cementing, your well will be controlled from the abnormal pressure. Further, we have to discuss the classification of cementing. You can say the class is from A to F. The class A, it is cheaper. The class F is costlier, which means in the class A, you can see that it will be, the cement will be done from the class A 0 to 6000 feet, where your formation doesn't require any special properties. If the formation is very blank and easily accessible without having any complexity, then I can go with class A, and this class A is also cheaper. And next we have to see class B. This class B, where the formation has high to moderate or moderate to high sulfur content. If it is exist, where I have to use this class B with the same depth 0 to 6000 feet. And class C, when the temperature is coming from moderate to high, then I have to use class C, the same thing which is 0 to 6000 feet. And class E, and next is class D. The class D is used moderately high temperature and pressure. So here the depth is 6000 to 10,000 feet, and class E, it is used under high temperature and high pressure. If I say the high temperature, high pressure, which is simply called as HPHT well. Once the temperature reaches more than 150 degrees Celsius and the pressure reaches more than 10,000 psi, which well is called as HPHT well. So where I have to use this kind of the class D cement or class E cement. And if I go further 10,000 to 16,000 feet, where you have to get extremely high temperature and high pressure, because once the depth is increasing, the temperature and pressure both will be increasing. So what we have to do, if we go very deeper, then we have to use class F. The question should come to our mind, why I can't use class F instead of using class A for the first 0 to 6000 feet? The answer is, it is economy. The class F has costlier, as I told earlier, and class A is not that much costlier, it is very cheap. So when your formation doesn't have any problem, then why do I want to invest unnecessarily this class F cement when the class A cement is enough to withstand that kind of the problems? So for that you have to check, and you have to always with the economy. Now we have to see how you are going to pump the cementing, which exactly fills with side of your well bore, which is called as annular space, from the bottom to your surface. That job is called as cementing job, and generally what we have to do name as primary cementing. In primary cementing there are 10 steps, 10 to 11 steps that we have to follow one by one. How do we do? So first we have to do with casing. The casing, if you say the casing, the bottom of the casing contain float shoe or guide shoe. Why it is called a shoe? Because the shoe is wearing in the bottom of our leg. So likewise it is the bottom of whole casing. That's the reason it is named as shoe. Here it is called as guide shoe or floating shoe. Once the floating shoe is entered to the bottom, the structure is like for few feet in the bottom, it might be thicker, as well as the shape is in the bottom is like spherical. Why it is like that? Because we have to make another thread with the another casing further. If I say that 8,000 or 9,000 feet, so you have to at least connect, it may be like 60 or 70, 80 casing pipes that we have to insert. So you cannot expect the hole is even. The hole, some of the hole may be enlarged, some of the hole may be caving during the entire time. So if it is like that, then what happens? If the casing, in the end of the casing is plain, it may be damaged. So for the purpose, it is like, it is like the last shape is more thicker, and it should be like it should be like thicker as well as, and it should be thicker as well as it should be spherical. So that is your casing shoe, or that is your guide shoe. That's what we have to see here. Now after 1 or 2 pipe further is connected with your joint, then we have to use one component which is called as floating collar. The floating collar, I told you, it may be like 2 or 3 joint of your casing that we have to put it. The distance between the floating collar and the floating shoe is called as shoe track. Now we have to do the nippling process. The nippling process means we have to make the special connection, like we have to use the tongs perfectly, and we have to put the casing one by one, and we have to complete. That process is called as nippling up. Now second step is we have to fill with our well with completely mud. That is called mud conditioning. Once in the drilling progress, what we do, we are using drilling fluid. That drilling fluid is formed as the mud cake inside wall of your well bore. So if it is fall like that, directly if I put cementing in the side, again in the annular space or side of the well bore, now it cannot be mixed together, because already chemical is exist. That chemical is coming from your drilling fluid. It becomes like cake. Again if I put casing, what happens? Again if I put cementing, what happens? It cannot be mixed together. For the purpose, what we have to do, we have to first completely clean up all those mud cakes. What I have to do, I have to completely fill with drilling fluid. The water, what I have used the drilling fluid, which becomes the mud cake, the same drilling fluid I am going to fill with the well. Once if it is done, then which is called as mud conditioning. Now this is step 3. Now we are going to test the pressure. Now first we have done the casing, then our well is completely filled with the mud. Everything is now ready. Now we are going to test the pressure, which means whatever the surface that we are going to pump with the cementing. Before that we have to check the trial whether any leak is exist in the surface flow lines. For that, what I am going to do, we have to put completely water with all flow lines, storage tanks, pumps, everything we have to fill with the water, and I have to increase slowly the pressure. I have to increase slowly the pressure up to 5 minutes. So if it is staying 5 minutes without decreasing the pressure, you can understand that there is no leakage. But if the pressure is dropping, that we can see through the monitor. If the pressure is dropping, then you can understand there will be some leakage. Through the leakage, your water starts to go out. So now you have to go and check where it is leaking, and you have to change it, because this is need when we are going to do the cementing job. We have to ensure that the cement should not go away, it should only go to that particular well. Once the pressure test is done, then you have to wash our well with the help of this wash. That wash is called as chemical wash, because the drilling fluid has in the annulus, it has the more thicker cake. The thicker cake, it cannot be easily removed. If you want to remove that, first we have to disperse it. Disperse means we have to completely break down into small piece. So for that I have to use this chemical wash. If I use this chemical wash, the whatever the thicker cake, it becomes like very thin, as well as it becomes like a gel, or like it becomes like a gel, or it becomes like semi-solid. So it can be easily pumped once we are going with the cementing. So further you have to pump with spacer. So once the chemical wash is sent, further I have to send with spacer. This spacer is creating the gap or separation between the cementing as well as the drilling fluid. As I told earlier, if you put drilling fluid followed by cementing, or cementing followed by drilling, what happens? It starts to mix together and contamination will be created, nothing will work. Our ultimate aim is we have to completely wipe out and remove the drilling fluid from the entire well, and we have to pump the cementing. If you do that, the cementing will be completely sealed in the formation. So for that, what we have to do, we have to use this spacer. First you have to use chemical wash. The chemical wash will help to disperse and thin your drilling fluid. Once it is done, we have to use this spacer. The spacer will make separation of your, further we are going to pump the cement as well as what we have pumped the drilling fluid. Now next step is you have to pump the bottom plug. The bottom plug structure is like this. You can see the structure is like a rubber mouth which is used to put the cover for the bottle. It might be used in the chemical laboratory or chemistry laboratory. It is like rubber mouth. So what it does exactly, even whatever we have done, we are separating through the fluid, it won't work, because if I put without any solid directly pumping the cement along with the drilling fluid, what happens? It may be spacer, it may be your chemical wash. Then what happens? Again contamination will be created. So I have to separate completely with the solid material. That solid material is called as bottom plug. Once if I do this bottom plug, this is like rubber, then followed by I can send the cement slurry, then whatever you have pumped earlier, the drilling fluid first, and second is chemical wash, and the third is spacer. So if you now if I put this barrier, then what happens? It cannot be contaminated together. So for the reason I am going to pump this bottom plug. Now the bottom plug is pumped. Now we have to prepare the cementing in the surface. Cementing is very simple. What the cement that we are using to make the house or to build the house, the same Portland cement that we are going to use here. So if you want to add some additives such as retarders, accelerators or dispersant, that we have to add, depends on your formation. But now consider, for understanding purpose, we add only some dry cement with water. We have to make first this cement slurry. This cement slurry should not be mixed before starting all the process what we have done. It should be done only in this step, because if we do, what happens? It starts to settle in the tank. So it should not be settled in the tank. For the purpose, we have to use only, we have to mix the cement slurry now itself. It should not be done earlier. In the cement slurry, what we have to do, we have to prepare two types of the cement. One is lead slurry, another one is tail slurry. Lead slurry has low density as well as high yield slurry, and tail slurry is high density and high as well as high yield slurry. So why lead slurry has low density? Generally, if you want to arrange or if you want to put weight one by one, which I am going to make weight one by one, what we have to do? We have to put the maximum weight in the bottom first, and we have to put the lighter weight in the topper. Like ascending wise we have to arrange. What happens if you put the lowest weight in the bottom and highest weight in the top? Now what happens? The lowest part may be broken. So likewise, what we have to do here, the tail slurry should be pumped in the last or bottom of your well bore, and your lead slurry should come to the surface. Correct. So for the purpose, now I have to pump in first the lead slurry. If I pump the lead slurry, followed by if I pump tail slurry, what happens? The lead slurry automatically comes to the surface and tail slurry will start to settle in the bottom. Now first the lead slurry is showed in the figure brighter manner, and tail slurry is showed in the darkened manner. You can see the lead slurry is coming first and tail slurry is coming next. Now what happens further? If I push with another displacing fluid which is pumped next time, the lead slurry starts to move to the surface and tail slurry starts to sit in the or settle up in the bottom of your well bore. Now whatever we have to estimate some amount of the slurry. The cement slurry only can be pumped to the well bore, which should be sealed your annular space. So after that we cannot put, because the cement, if we use excessively cement, it will spoil our economy. For the purpose, what we have to do, once we have done the cement slurry and prepared, still it will be existing only in your inside pipe, because some of the slurry cannot be completely gone to the annular space. So for the purpose, I have to push everything to the side of your well bore, then I have to directly use some spacer, it may be like displacing fluid. So again, if you come to the displacing fluid, directly if you use along with this tail slurry, then it starts to mix together, it starts to contaminate as well as spoil your cementing process. Now what I have to do, again I have to preventing this two mixing. So again I have to separate. For the purpose, I am going to use another plug. That plug is called as top plug. This top plug is also like rubber, it is completely separating the whatever we have pumped the slurries, as well as we are going to pump the spacer fluid. Now we have to displace the slurries with the help of plug as well as displacing fluid. Displacing fluid, once the top plug is sent, further we have to use this displacing fluid, which helps to further your cementing will be seated completely to your annular space. Now how it works, if we say the process, now we have pumped the cementing. The question should come to our mind, once if I put to the bottom plug, the bottom plug starts to settle in the float collar. So if it is settled, mean this is also plastic or solid. The solid, further how the cement will go to the bottom, because there won't be any communication or any hole. Now there will be one diaphragm, the diaphragm which is exists in the bottom hole. When I am going to give the pressure more and more, because I have to give the pump with the help of cement slurry followed by the spacer fluids or some other displacing fluids. Now what happens, the pressure difference will be created with the bottom as well as top. So this diaphragm will be ruptured once the pressure is getting high, which is exist in your float collar. Now it will be ruptured and the hole will be created. Now the cementing starts to flow to the bottom of the hole, and further if you displace with any kind of the further displacing fluid, then it starts to come to your annular space. Now top plug is sent, followed by the displacing fluid is also sent. Now the cementing completely will be coming out from our inside the well, and it should come directly to the annular space. Once it is come, this bottom plug and top plug starts to get together, correct? Now what happens, once it is stick together, then we can understand that whatever we have to do the cementing job, that is completely done. And now whether it is coming back or not, that we have to see. Already in the floating collar there will be like a round shape in the diagram. If you see, the round shape is valve that will control the flow back. If the cementing is not settled or if it is going to annular space, it should go, but if it is not going, then it starts to come to flow back to your again casing pipe or inside the casing pipe. It should be prevented. So in the floating collar there will be flow back valve. That valve will control the whatever the flow of the cementing which is going to return. Again we have to see with the help of some sensors whether the cementing is coming back or not, which means the valve is working or not. How do we know? We have to check the cementing is coming to the pipe. The ranges should between 2 to 5 bbl. If it is more than 5 bbl, then the cement is not getting to the annular space and the cement is coming to your again well bore only. So whatever we have done, it is not worked, that we can understand. First the casing is run, the bottom of the casing is called as float shoe, and after your casing 2 or 3 casing further joint, then we have to fix the float collar. The round shape already told you it is your valve. The distance between the float shoe and float collar is shoe track. Then second step is we have to condition with the drilling fluid. You can see the all brown color, this brown color is completely drilling fluid. This drilling fluid will help to completely disperse whatever the mud cake already it is created by the same drilling fluid used in the drilling process. Okay, fine. Then we have to pump the spacer fluid. This spacer fluid will help to completely separate the drilling fluid as well as the cementing. Further that we are going to do. Once the spacer fluid is pumped, again we have to put the bottom plug. This bottom plug contains the rupture. It is simply wiper. You can see there is no brown color exists inside your casing pipe, which means it's completely wiped out whatever the thing. That's the reason we are pumping this spacer fluid as well as this bottom plug. So this bottom plug completely wipe out whatever the remaining things is exist. So further it will be very helpful for the cementing. It can easily become more stronger. So when this bottom plug, once it is sent, followed by the cement is sent, you can see the cement is sent. Once the cement is sent, then we have to put the top plug, correct. So this top plug, after putting this top plug, again we have to use this displacing slurry. This displacing slurry completely help to make exit of all cementing from the wellbore to your annular space. That you can see here, the all spacer fluid comes in, and here you can see here all cementing is fixed within the annular space. Now we see, now once this bottom plug is entered, you can see here completely the cementing is exist here. The cementing is not passed through here because it is solid. Now how it works, it contains the diaphragm. This diaphragm will be ruptured once if we give the maximum pressure. Then the hole will be created. With the hole, further we are giving the more pressure. Then what happens, the cement starts to completely come out here. You can see, so all the cements completely come. Then your top plug will start to settle in the bottom plug. Once this top plug and bottom plug becomes together, you can understand that all cement is completely filled with the annular space. There is no cement exist in your well. That we have to understand here. And we have to check the flow back, whether the cement is done properly in the annular space or not. That how can we see? If you see, the cementing is again coming to flow in to your well casing or inside your well bore. Then you can understand, if it is more than 5 bbl, we can understand that the cementing is not done properly. The cementing, if you want to do properly, if it is like properly done, there won't be more flow 2 to 5 bbl. Now the procedure we have done for the primary cementing. Now we have the doubt, in some of the formation may be dealing with some other like lithological properties which may create the less bond in the cementing, or the cementing cannot be completed in some interval. So for that, what we have to do, we cannot go with again primary cementing, because already annular space is filled completely with cementing and it is settled, it becomes like solid. But in the specific interval, it may be like in the mid or bottom or top, it may be some leak will be exist. If the leak is exist, then what happens, where the fluid starts to enter to the annular space, and this water is salty and which will create the corrosion. Again it will make the question to the wellbore stability. For that, what we have to do, we have to insert the bond log, that is called cement bond log. That we have to see, and we have to check where the cement is not filled properly. It will identify and it will give the result to us, in certain area it is not filled properly. So what I am going to do, I am going to take that specific interval and I am going to give only cementing in the specific area. That process is called as secondary cementing. So this secondary cementing is also called as remedial cementing. So it is helping to repair the primary cementing problems as well as treat conditions arising the well bore after constructed. So even if it is like if you are done in the rig over job, so where if it is damaged, then again we have to go with secondary cementing. This secondary cementing we can use two techniques. One is squeeze cementing and another one is placement of plugs. Generally we will use these two techniques. Now we have seen in this lecture the primary cementing as well as secondary cementing. So this video will be helpful for the basic operations in the cementing. So I would like to thank you for listening.